So is mob breeding sheep better than the standard breeding of St. Croix sheep that everyone does? Well, first we have to define what is mob breeding. Mob breeding is when many males are allowed to breed with all the ewes. We don't care about the pedigree. We don't care about who breeds with who or the offspring. We just want the best males that we have to breed with all the ewes and as many males as possible. This increases our genetic diversity in the flock, so it's a really good strategy for a closed flock. The second part of mob breeding is that the worst offspring that's produced from these unions, or any offspring that needs human assistance, or if they fail to thrive, they're culled. So we're culling the worst, and almost anybody can pick the worst offspring out of a flock. It's a lot harder to pick the very best. You're also eliminating any animals that need deworming, that need vaccines, that need to be having kind of antibiotics. Any animals that have trouble lambing, that don't have good flocking instinct. So you're culling out the worst part of your flock each time, and you're letting as many males breed as possible. Mob breeding is based on the natural selection process we see in nature. By culling the unfit, mob breeding produces a gradual improvement to the genetics of the flock. Mob breeding preserves as much genetic potential as possible inside a closed flock. A lot of the good genetics that we see in an animal and are being carried by an individual are not always being expressed. We definitely don't want to cull any good genetics. In mob breeding, we only want to cull the obviously bad genetics of the very worst animals in the flock. And it's pretty easy to do because anybody can see which ones are the worst animals. So in comparison to mob breeding, what is standard breeding? The standard breeding practice is to let only the best male, a single best male, is allowed to breed with as many females as possible. So the strategy behind standard breeding is that you're culling all the inferior males before reproduction even begins. Now there's some problems with this strategy. One is, when you're using a single male for breeding, that's really a hard limit for your genetic diversity. It lowers it down to just what this one single male can produce for the male side. And so the breeding selection on using just one male is based just on these genetic traits that are being expressed in this single male individual. He may have other genetics inside of him that you can't see, but you're only looking at what you can actually see. One genetic trait you can't see inside this male are all the female traits he might have, like will his female offspring be a good mother? Will they have good milk production? Will they have easy lambing? Well, you don't know that because it's a male, so you really can't tell. Also, is he resistant to some sort of genetic disease? Well, because he's not been exposed to it, you don't know. He could be spreading QQ scrappy resistance, where it's not resistant to scrapie all through your herd, and you wouldn't know. Now, here's a chart from the United Kingdom, and it's trying to figure out the cost of the ram for all the ewes it's going to breed. It's a 600 sterling ram is the purchase price. And just for 30 ewes, it's much cheaper. But once you get on up to about 100 ewes for this one ram to breed, then the cost per lamb goes down extremely. But there's other costs, and we're going to talk about that. One of the greatest costs from using a single ram is inbreeding and lack of genetic diversity. In this chart, the blue box is a male ram A, and the pink circles are ewes, and there's 7 ewes being mated to one male. And so for sake of illustration, let's say that each ewe has 2 offspring, 1 male and 1 female. And if you were to slaughter these offspring or not let them breed, then you wouldn't really have a problem with this next generation. However, when this generation does breed with each other, if it's a brother-sister match, it'll have a 25% coefficient of inbreeding, which is very, very high. And with this number of offspring, there's really only one chance in 7 that the animal would breed with its own sibling. But the real problem is not that one animal might breed with 1 chance in 7 of breeding with its own sibling, but that every one of these offsprings is now a half sibling, because if ram A is the grandfather of them all. So no matter who they breed with, they've got a 12.5% coefficient of inbreeding, which is very high. Anything above 5% is not a good idea. This is why using a single male in standard breeding is an absolute disaster when it comes to the long-term genetic diversity of a breed. And it's destroying them, really. Now, here's how you would do it mob breeding. You would have 7 different rams, A, B, C, D, E, F, and G, mating with 7 different ewes, 1 through 7. And all of the offspring produced by these 7 males and 7 ewes would be as genetically diverse as possible. And so, yes, there could be a brother-sister mating, sibling mating, which would create a 25% coefficient of inbreeding, but that is only 1 chance in 7 and not likely, really. The real benefit of mob breeding is that since you start out with as many males as females, all the other matings here will have a 0% coefficient of inbreeding. If we look at just this generation, now there could be related ancestors back up the line, but what we're looking at just here produces a 0% coefficient of inbreeding. And preventing inbreeding by having an equal number of males and females is a very natural principle. This is a genetic principle called Fisher's principle, and it explains why nature always has a sex ratio of most species that's approximately 1-to-1 between the males and females. And the way nature is set up is to prevent inbreeding and then let the environment cull any that are inbred and can't function in the environment. But it's not normal to have a single male to breed all the females. So one of the principles of mob breeding is to follow nature and allow the breeding of a large number of males to all the females and not use just a single male because of all the problems it causes. And one of the natural things that happens when you have all these males, they have to fight for the right to breed. They have to fight each other. And so the strongest male will breed more. That is the male that has the strongest sex drive. And so it's very important that we not lose the animal's sex drive because we're doing it through artificial selection by man, just picking them based on some other attribute. A lot of males are picked based on the size of their scrotum. It's measured, and they look at that, and they think that's a good indication of whether or not it's got good reproductive ability. And yeah, it's got the equipment, but what if it's got some other problem that makes it just not want to breed? And you could be letting this genetic code into your flock because you're not letting the animals fight like they're supposed to. The males fight for the right to breed. Nature tells us that the most dominant animal has the right to breed more females than an animal that's not dominant. And we fail to understand that. We think we can pick out something based upon size, and this is a trait that's being lost. And so it's really going to hurt the breed in the long run. If the rams can't fight to breed, you're going to end up with a lot of docile rams that won't have an interest in breeding in the long run. Now, the other thing you want to do is only keep a ram for about 2 seasons. If you got a dominant ram, he's gonna breed with everybody over and over again. You want to cull that ram, just like it happens in nature. In nature, the rams get culled first by the environment, by protecting the flock. They stand up to a predator, and they get culled first. And the ewes live much longer than the rams do, and that affects inbreeding as well. So in mob breeding, we keep the ewes as long as they are productive and bear offspring, because the ewes can only have 2 offspring a year, 2 or 3 at most, and they're really not the source of any kind of inbreeding. So you want to keep the ewes as long as possible. And we want to encourage the genetics of the ewes that bear young over many years. So if you have a lot of older ewes that are still bearing, then that genetic trait is getting spread throughout your entire flock. And so all your ewes at some point in the future will live many years and bear a lot of young for you. So while you want to keep the ewes, you want to eliminate the rams after the second season. And one reason is you want to eliminate the future chance that any of these rams are going to breed with their own mother are close siblings, which is a very high coefficient of inbreeding. So if the rams are culled after the second year, they can't inbreed with their close relatives. The other thing to consider is that each year is a full generation to a sheep, as a ram can breed at 7 months after a 5-month gestation period. That means that the ram that was conceived last year can actually breed his own mother the next year. So that's bad, but that can also be good in a way. The way to use it for your good is to understand that each time a generation comes through, it separates out the ewe from all the future rams that are downline by a full generation. It also lowers the inbreeding. So when there's only one generation of separation and a mother is bred to her son, there's a 25% coefficient of inbreeding, which is very high. With 2 generations of separation, that is, a grandmother is bred to her grandson, there's only a 12.5% coefficient of inbreeding. With 3 generations of separation, which would be a great-grandmother to a great-grandson, the coefficient of inbreeding is lowered down to 6.25%, which is almost acceptable. And when you get 4 generations of separation between the ewe and the rams that were born that year, there's only 3.1/8% of coefficient of inbreeding, which is acceptable. And most people don't realize that each year is a generation to a sheep, and so it gives you some advantages in breeding. So by eliminating the younger rams and keeping the older ewes, you're lowering the inbreeding coefficient because you've got this generational separation. And this generational separation works better in a much larger flock. So if you've got like 100 or 200 head of sheep, then you're going to have a lot better results through this separation of the generations by culling all the rams after the first or second year. So why is avoiding inbreeding so very, very important? Robert Bakewell was one of the earliest breeders to use artificial selection to produce new breeds of sheep and cattle, and he relentlessly bred a single male to many females, which is what we're doing today. And Bakewell's inbreeding did produce results quickly, and everybody was amazed at what he did. The problem is, Bakewell's inbreeding is apparently the cause of the spread of prionic diseases like scrapie. Apparently, he ruined their genetics and caused the scrapie epidemic. Here's a reference in Wikipedia from a book that quotes from that time period. It says, as soon as scrapie broke out in Comer's district and the surrounding areas, all the aristocrats pointed a finger at Bakewell and his breeding practices. So there is no scrapie ever found in the mouflon, which is the ancestor of all modern sheep, and there's no scrapie ever been found in the St. Croix breed because it's not been inbred at this point. This is why mob breeding is so vitally important, and also working with a breed like the St. Croix that's not been in the backyard breeding business by all these different breeders who line breed and overbreed and inbreed and destroy the genetic code. Now compare this to the Suffolk breed here that we see, and also the Hampshire breed. They've both been artificially selected over hundreds of years, and they're just chock full of these genetic defects. To prove this point, I asked ChatGPT, artificial intelligence, to help me search the web and find the sheep breeds that are most affected by genetic diseases. And the Suffolk and Hampshire come out near the top, while the St. Croix appears to be immune to these genetic diseases because it's not been inbred. So if you look at scrapie, the Suffolk and Cheviot breeds are most affected, and there's never been a documented case of scrapie in St. Croix sheep. This ovine progressive pneumonia, all breeds are susceptible, and St. Croix can be infected by it, but there's been no documented deaths from OPP in St. Croix sheep on the internet. The Spiderland syndrome and Batten's disease, the Suffolk and Hampshire, seem to suffer from this. Again, they've been over-engineered using Robert Bakewell's technique of using a single ram and many females. Now, I won't go through each one of these diseases, but you can see that all the major sheep breeds are affected by these genetic diseases, and they're the most popular breeds. They're also breeds that are being protected by a pedigree. So you would think the pedigree would stop the inbreeding, but for some reason, it's just not working. Now, here's a pedigree of a ram I bought several years ago. It was a beautiful animal. And one way that this pedigree may not be accurate is that the animals that are listed on it from these different farms, they may be closely related. If somebody in a previous generation took a single ram and mated it with many ewes, then the animals that appear to be from different farms could be half siblings. And so there could be a lot more inbreeding than what is obviously listed here on the pedigree. The other way a pedigree could be invalid is that there's a huge financial incentive to cheat and to line breed and use a really good ram more than once, but say it came from a different ancestor. And the reason is they're trying to get the largest and strongest looking ram they can because there's so much money to be made in these stud fees and other benefits you get from having a winning ram that wins all the different contests. So pedigrees are just what a person says they are. They're not actually the truth. And regardless of whatever's written on paper, all these breeds that are affected by genetic diseases, they're protected by pedigrees. There are pedigrees for these animals out there, and they've got the same problem as the ones that aren't pedigreed. You've got this problem through all these well-known breeds because of the way that we raise and do artificial selection. So artificial selection is really destroying the genetic potential of our livestock animals because it's following the method of Robert Bakewell and using a single ram for many ewes based upon just the phenotype, just what can be expressed in a single animal. And that is not the correct way to go at this. The process of genetic selection to improve a livestock animal breed, it's really just too complicated, too complex for any human to do correctly because he doesn't have all the information he needs to make the correct decision. And so to decide to use a single ram just based on how it looks, just based on the phenotype, and not being able to see the genotype or all the genetic information that's inside that ram, there's no way you can possibly do that correctly. You're gonna make some errors because you're not letting nature do it. On the other hand, with mob breeding, it's based upon natural selection like nature does, and this is the only way you can really restore the genetic potential of our livestock animals because you're letting the strong survive, you're letting the ones that have all the genetic data that works in a positive way for that animal and for all their offspring, you let these succeed. And then just like the predators do, man becomes his own predator of these animals, and he culls the weak, the sick, the lame, the old ones, and that brings the genetic potential up in the entire flock. But you have to let them breed freely and let nature do what it does best. And the way nature works, it randomly associates genetic data in different new patterns that's never been seen before. Each new animal is like a snowflake. It's got a brand new set of DNA combination that's not been seen before. And so it generates positive and good outcomes. It also generates the bad outcomes. And so all we have to do as humans is to cull the bad outcomes. We keep the top 60, 70, or even 80% of the animals, and then just cull the 20%. So we're taking the worst animals to the slaughterhouse and turn them into meat, and we're keeping the good animals. And it's that simple. We don't have to go through and try and select one super ram because we can't do it. We can't do it right. And the other crime that we're committing with artificial selection by man over who breeds and who doesn't is that we're not selecting the animals based upon their environmental pressures, like the parasitic worm loads, or that they need to have antibiotics, or different things, or lambing, they need assistance lambing. While natural selection would cull these animals for us, and we wouldn't have all these labor requirements and all these inputs that we have to give to these animals. And it's important to note that before the introduction of chemical dewormers in the 1950s, every sheep had to rely on its own ability to shed worms in its environment. Now, some of these sheep, like the Dorper, was raised in a desert environment without hardly any worm load. But the St. Croix came from an island that had a lot of worms. But where they lived before 1950, they had to be able to shed their own worms. So now, because of using artificial selection with a single ram, many females like Robert Bakewell did, and not using mob breeding and letting the strong survive, nearly every sheep now requires these chemicals to survive. They can't make it without dewormers. They can't make it without antibiotics. They can't make it without all these different vaccines. They just can't do it. And we put them there because we're not doing mob breeding. So one of the greatest benefits of mob breeding is that it lowers your required inputs, all the chemicals you got to buy, antibiotics, vaccines, and it also lowers your labor cost. And so what this means is that one person can raise a lot more sheep instead of being down to like 20 or 30 head here in Tennessee, which is the average size of a sheep flock in Tennessee. I could raise 10,000 head. All I need is a good perimeter fence and enough guardian dogs. And I could raise a flock just like they do out west up in Wyoming. And so that's my goal, is to take the St. Croix sheep breed and make it totally bulletproof, where it needs no human input, and make it larger and better, more suited for what people want, and keep it 100% chemical free, so that people can have organic food or better than organic food. And that's my point. I'm doing a genetic work here with these animals, but I hope to open up the entire southeast United States to becoming a large sheep producing area for the United States, because sheep are much more productive than cattle. They have twins. They produce more. They have a better feed conversion ratio of like 6 to 1 instead of like 12.5 to 1 for cattle. They're much more efficient, and people love them, and they're easy for anybody to raise. And that's really what my goals are. Now, I want to give some credit to this fellow named Bjorn Johansson. He has a YouTube video called Mob Breeding, and he is very well spoken, and he described exactly what I've been doing for a long time. I didn't know that's what you called it, but he's got a good video. He's also got a Facebook page, and I'll put links down below so you can listen to him. A friend of mine in Oklahoma, he contacted me. He saw how I was describing my operation, and he put me in touch with this YouTube video by Bjorn Johansson. And I want to encourage you to watch that as well, and look at the link down below in the description. I also want to encourage you to go to our certified chemical-free website. We're developing a list of farms that grow their animals and their food without chemicals. It's beyond organic. The organic certification really is not adequate. It's got a lot of chemicals in organic food now. But these are the farms that grow their food completely chemical free. Many of them use techniques like we've discussed here. Well, thanks for listening to me, and thanks for watching the video.